All right, here we go. Um, so I thought we'd do something fun and educational today. Since I'm going to tell you guys not to go to school. All 10 subscribers, hopefully you didn't enroll to any kind of college or high school program or anything like that. Hopefully you were at home figuring this out with me. So I'm going to teach you guys how tunnels are constructed. Because, like, I don't know. I see that tunnels are underwater. A lot of times, like sometimes you go over like a bridge or something, and you go in like a tunnel and it's underwater. Like you get that concept, but like, how did you guys build a tunnel? Like we're like scuba divers doing this construction? Like, I don't know. So we're gonna figure it out right here.
From subterranean roadways to the network of tubes that make up many of the world's great mass transit systems, and the means by which we move waste away from urban areas, tunnels are among the most critical pieces of
I didn't even think about the subways, because like that's even crazier than underwater. Like there's like a whole train railroad system underneath the city. Like I'm just walking on top of it. Does that make sense? No.
infrastructure that keep our cities moving. However, unlike above ground infrastructure, which becomes a visual part of any city upon its completion, the scale, engineering complexities, and methods required to construct and operate our tunnels goes largely unnoticed by the millions of people who use them every day.
I noticed.
From digging in the dark to ensuring safety, minimizing disruption, and bringing fresh air underground, these are the critical challenges that must be overcome to make our world's tunnels a reality.
But like, firstly, like, who thought about this, bro? Like, who was like, they're like, hey, man, we need to get over there, and they're like, all right, well, the elevation's not high enough for a bridge. They're like, yeah, you're right. I don't know what else they said, but then they're like, all right, let's just dig a hole and let's go through there. I don't know what else could have gone through their mind, but somehow they came up with the concept. We're gonna dig a hole and we're gonna go through the hole to get to where we need to go. Like tunnels, like the trains going through mountains. Like who was just like, man, like if I was a train person and I was building my train track and I got to a mountain, I would be like, well, we fucked up. Like we shouldn't be at this mountain. And they were just like, no, we'll just go straight through the mountain. What? Who thought of that?
The methods used to build the majority of today's tunnels mean that, aside from a number of scattered access sites across their routes, the work to form these structures goes largely unnoticed by the population. By contrast, the earliest tunnelling method, known as cut and cover, was one of the most disruptive processes a city had to endure to construct vital below-ground infrastructure. With this method, engineers would first dig a trench, then lay bricks to form the tunnel walls, before backfilling the excavation and reinstating the surface above. This approach...
Hold up.
The excavation and reinstating the surface...
So they dig the whole thing out, then build their stuff. Oh shoot. Then they build their stuff, and then they put the dirt back on top of it. And then there's your tunnel. That's I mean, that's a way of doing it. I mean, I don't see anything wrong with that method, but I do see how that could have taken a long time.
This approach required large stretches of the streets above to be closed for extended periods, creating congestion. In some instances, properties along the route had to be acquired before works could proceed.
Acquired. What's that called, dude? Eminent domain or something like that? That's crazy. I think that's what it's called, eminent domain. Just take your shit.
The cut and cover technique was used to construct London's Metropolitan line, the world's first underground railway route. The impact of the works to form this line can still be seen today, in the numerous sections of track that have been left exposed, where buildings were not reinstated on completion. Today, tunnel boring machines, or TBMs, are used to construct tunnels in urban areas.
What is that? Like, who thought of this? Who was like, yo, let's make this thing. Like, look at all, this is like an airplane. You know, like, you ever see like the commercial jets? And you, like, even like DJ equipment, where it just has like a million buttons and a million, like, What does all this do?
eliminating much of the disruption that tunnelling schemes caused in the past. Operating on the same basic principles as the tunnelling shield developed by Sir Mark Isambard Brunel during the construction of the Thames Tunnel in the 19th century, TBMs are able to excavate material and line the tunnels that they form in one continuous process, increasing efficiency
Where's the dirt go?
and greatly improving safety.
Look at this. Oh my god, it's like a train or
Due to
something.
their size, varying between 150 and 200 metres in length, TBMs need to be delivered to their entry sites in pieces before being lowered into access shafts and assembled. While variations of TBMs exist for different soil,
You know what? I just think about this because, like, construction, right? Like, I just wonder, like, how hard. Like, construction seems to be, like, a pretty solid job. But, like, how hard is it, like, doing this stuff? Because I'm just, like, look at all these people. I think there's people over here. Like, this is some form of machinery. There's some guys over here, some guys over here. But, like, I feel like if I was a construction worker, like, I could pretty easily slack off. Because, like, I don't know. Who's in charge of putting this thing down? That's, like, one dude. Maybe, like, one dude and a couple guys, like, making sure it goes in the right spot. But I'm just, like, I'd be in the trailer eating some snacks or something. Like,
entry sites in pieces before being lowered into access shafts and assembled. While variations of TBMs exist for different soil types, the key piece of machinery common to all systems is the forward-facing rotating head, which is lined with a series of blades able to cut through all manner of rock and clay. Spoil from the excavation is funneled behind the cutter head and transported back towards the tunnel entrance via conveyor belts. Much of the spoil from the construction of London's Crossrail, one of the world's largest infrastructure projects, has been transported to the Thames estuary and used to create a vast new wetland sanctuary.
what?
As the TBM moves forward, precast concrete shells are brought in to form the lining of the tunnel behind it, preventing the surrounding earth from collapsing back into the void. Due to the costs and logistics associated with removing them, many TBMs, like those used to construct the Channel Tunnel, are simply driven off into the earth and left in place once they complete their work. However, in recent times, and with their costs increasing, a number of schemes have removed their boring machines on completion, ready for use on future projects.
How do you leave it? I don't understand.
While the physical construction of a tunnel is a
where does it go?
considerable engineering feat, the ongoing operation and management of these structures can be just as challenging. Regardless of their use, monitoring tunnels throughout...
See, look, this is some kind of, like, hill. I assume this one was not a hill. But I'm like, we fucked up. Like, we gotta start over. We gotta, like, make this one go around or something. Or on top of the other one. How do we just decide, like, we're gonna dig through this mountain?
throughout their lifespan to ensure their ongoing safe operation is paramount. Ventilation is critical, particularly with road tunnels where high levels of pollutants, including carbon monoxide and nitrogen oxide,
I never thought about
are
that.
continually discharged. Numerous methods are used to improve the quality of air in tunnels. While some systems force clean air through these underground spaces, others focus on the extraction of pollutants through ventilation ducts, which in turn draw fresh air in.
I'll be seeing the big fans in there, and I thought it just got hot. That's crazy. I thought it was just hot in there.
We've used SimScale to simulate how such a system works
What
on
the hell is
Central
this?
Artery Tunnel project in Boston, a scheme which reroutes the central artery of Interstate 93 through the Thomas P. O'Neill Jr. Tunnel.
What the hell is this?
With more than 150,000 users worldwide, SimScale is an easy-to-use cloud-based engineering simulation platform that enables everyone to create powerful, high-fidelity simulations in a web browser. The platform can be tried for free through the community account, which gives access to thousands of public simulations to promote knowledge sharing and to crowdsource advice.
I give so much credit to like engineers because like I didn't understand what this was showing me, but I see it now. So that red stuff or the blue stuff that it once was is like gas. I thought it was water, and I was like, why are the vehicles in the water? Or like, what are those?
The ventilation techniques used in many tunnels work in tandem with fire suppression systems to clear smoke in the event of fire. Within road tunnels, extensive traffic management and signalling systems are in place to reduce the risk of accidents between vehicles, which could bring operations to a standstill in a considerably confined space. For motor vehicles,
See, that's some drinks right there.
in a considerably confined space.
I thought that was because it was hot.
For motor vehicles, electronic displays provide up-to-date information to drivers on which lanes are in use and alert drivers to obstacles ahead. It is also typically forbidden to change lanes while travelling through tunnels
But people be doing it. I be seeing them. They be doing it. They don't care.
to minimise the risk of incidents between vehicles. Many road tunnels also feature traffic control systems outside of their entrances to prevent vehicles sitting stationary in congestion once inside. In the case of metro tunnels, sensors on trains and signals through the length of a tunnel's route alert drivers to the status of other trains ahead, allowing them to remain at a platform in the event of an incident. In the unlikely event that these systems are unable to prevent an accident within the tunnel, emergency systems alert drivers and passengers to abandon their vehicles and proceed to the nearest refuge or escape point. In addition, many
So is that why? So like a lot of the tunnels I have gone in, they always have like a walkway on the side, and I always thought that was like a pedestrian walkway. But I'm like, how would they even get in here? Like, it doesn't seem like they would even be in here. But that makes sense. So if something happens, you get up there and you walk down. We learned a lot today.
modern tunnels are now built in pairs, with traffic travelling in a single direction to further reduce the risk of a head-on collision. This approach allows passengers to pass through to the safety of the alternate tunnel in the event of an emergency. Though they often go unnoticed, tunnels are, in fact, the arteries that power our cities. Passing beneath our feet and transporting millions of people every day, these critical pieces of infrastructure are truly in a world of their own. If you enjoyed this video and would like to get more,
I learned a lot, but I'm still asking a lot of questions because like the tunnels, like the machine they showed us how to do it, I don't think it makes up for all of them. And then like I want to go back, like, because that was a very sophisticated machine and it had a lot of parts on it, and we've had tunnels for eons. Like like the old school train tunnels through the mountain, who made that? Who did that? What did they use? Was they just really just breaking rock? I don't know. So I still got a lot of questions. So hopefully you learned a lot. But don't go to school. It's all right here. We're going to go through it.
Life of a Kennedy, James Dean rollout. Summer spent in places most my people never know about.